When developing applications with Angular, it's crucial to adopt best practices to ensure maintainability, performance, and scalability. Here are some common Angular architecture mistakes to avoid. 1. Neglecting modular design. Mistake: placing all components, services, and directives in a single module, typically app module. Why it's bad? It makes the application harder to maintain, test, and scale. Solution: break the application into feature modules. Examples: user module, admin module. Use lazy loading for larger modules to optimize performance. 2. Overusing component logic. Mistake: embedding too much business logic directly into components. Why it's bad? Leads to bloated components, making them hard to read, test, and reuse. Solution: delegate business logic to services. Components should primarily handle view logic. 3. Ignoring state management. Mistake: directly managing state across multiple components without a unified approach. Why it's bad? Leads to scattered and inconsistent state management, making debugging difficult. Solution: use state management libraries like ingRx, Akita, or RxJS behavior subjects for predictable state handling. 4. Improper dependency injection, DI. Mistake: registering services in the root module unnecessarily or failing to scope services appropriately. Why it's bad? It can lead to memory leaks and unwanted service instances. Solution: use the provided-in option in services for better scoping. For specific modules, register services in their respective @ing module. 5. Overcomplicating routing. Mistake: using overly complex route configurations or neglecting lazy loading. Why it's bad? Increases the application's initial load time and makes routing harder to manage. Solution: simplify routes and implement lazy loading for feature modules to improve performance. 6. Not optimizing change detection. Mistake: failing to control change detection mechanisms, leading to performance bottlenecks. Why it's bad? Can cause unnecessary DOM updates and degrade performance. Solution: use on-push change detection strategy when possible and leverage Angular's trackby in *ng for loops. 7. Hard-coding values. Mistake: hard-coding strings, configurations, or URLs directly in components or services. Why it's bad? Makes the application less flexible and harder to update. Solution: use environment files for configurations and constants files for reusable values. 8. Skipping unit testing. Mistake: building applications without sufficient unit tests or end-to-end tests. Why it's bad? Makes the application prone to regressions and bugs. Solution: use Angular's built-in testing tools with Jasmine and Karma. Prioritize test-driven development, TDD, when feasible. 9. Not handling errors properly. Mistake: failing to implement global error handling or showing raw error messages to users. Why it's bad? Poor user experience and potential security vulnerabilities. Solution: implement a global error handler using Angular's error handler and display user-friendly error messages. 10. Ignoring performance optimizations. Mistake: neglecting optimization techniques like AOT, ahead of time compilation, tree shaking, and lazy loading. Why it's bad? Leads to larger bundles and slower load times. Solution: always enable AOT compilation, use tree shaking, and optimize Angular's production build with ing build, prod. 11. Poor component communication. Mistake: using inefficient methods for communication between components, such as event emitters or shared services everywhere. Why it's bad? It can create a tightly coupled system, making debugging and refactoring challenging. Solution: use at input and at output for parent-child communication, and shared services or state management for sibling components. 12. Neglecting security practices. Mistake: not sanitizing inputs or failing to protect against cross-site scripting, XSS, and cross-site request forgery, CSRF. Why it's bad? Makes your application vulnerable to attacks. Solution: use Angular's built-in security features like DOM sanitization and always follow best practices for securing APIs and sensitive data. 13. Failing to plan for scalability. Mistake: designing an architecture that only works for the current requirements. Why it's bad? Makes it harder to accommodate future features or growing user bases. Solution: plan the architecture with scalability in mind, leveraging lazy loading, modularization, and proper dependency management. By avoiding these common mistakes, you can build an Angular application that is robust, maintainable, and ready for future growth.